All right, everybody. Today we're going to be talking about the chemistry of biology. And you might be saying to yourself, well, I didn't sign up for a chemistry course. And you're right. However, in order to understand most of the concepts that are fundamental to biology, things like chemical bonds and where the energy comes when you eat your food, or how is it that respiration takes a carbon molecule and turns it into ATP, etc., 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 we need to understand some more fundamental things about the chemistry of life. So let's start off with atoms. Atoms are the building blocks of life, and atoms are these incredibly small things. The radius of a carbon atom is about 90 trillionths of a meter. A meter is a little bit more than 3 feet, and a carbon atom's nucleus is 90 trillionths of that. The mass of an atom is made up by the protons and the neutrons. We'll talk about electrons later. Those are there. They generally do not count toward the mass of an atom. So in the nucleus of an atom, you have the protons and the neutrons, and sort of flying around the nucleus, you have the electrons. This is what's called the Bohr model. And there are actually much better ways of understanding how the arrangement of an atom works. But for biology, this one's sort of good enough. When you take chemistry, if you've ever taken chemistry before, you'll see other models for this. But for us, for today, for this semester, the Bohr model is going to be just fine. So I've said that there are protons and neutrons in the middle of, in the nucleus of an atom, in the very center, and the names might have tipped you off to the fact that protons have a positive charge, neutrons have a neutral charge. The electrons flying around this nucleus have a negative charge. Now, what does it mean to be charged? That's a pretty difficult question to answer, but you can think of it like this. Positive things attract negative things. So opposites attract and likes repel. So positive things will repel positive things. Negative things will repel negative things. Okay, so protons are positive, neutrons are neutral, electrons are negative. So let's talk about the periodic table for a moment. The periodic table is on the wall of most science classes, and it's arranged according to the number of protons. So remember, those protons are the positively charged things in the nucleus of an atom, and the number of protons determines what kind of element you're looking at. So elements are these sort of fundamental units. So each letter or each symbol, sometimes consisting of 2 letters on the periodic table, is an element. And some people confuse element and atom. They're not the same thing, but they are closely related. An atom is the smallest unit that you can break an element into and have it still be an element. And I'll explain this a little bit more. So the smallest amount of gold that you can have is 1 atom of gold. You can't have a half atom of gold. Okay, and so that's where atom comes in. Atoms are the smallest unit of particles that can still be an element, that can still be one of those things on the periodic table. So H stands for hydrogen, C stands for carbon, He stands for helium. They get a little bit weirder because of different conventions. Sodium is Na, iron is Fe. And the periodic table arranges the elements according to their number of protons. So for instance, carbon has 6 protons. You cannot have carbon with 7 protons. Why not? Because that would be a different element. That would be nitrogen. You cannot have an atom of carbon with 5 protons. Why not? Because an atom with 5 protons is boron. Okay. The number of protons determines what kind of element is that you're looking at. This is also referred to as the atomic number. You'll see it is the number represented in the periodic table next to the symbol. The whole number, that is the number of protons. Then you'll see this other number, which is most often fractional here. So carbon is 12 and some change. 12 and a few digits, I guess I should say. And what does that mean? Well, that means that carbon weighs about 12. This is called the atomic mass. So the atomic mass is, again, the number of protons added to the number of neutrons. But why is it fractional? How is it that you can have something that is 12.001? Can you have like partial protons? You can't. Can you have partial neutrons? You can't. Are we adding in electrons? No, we aren't. What's happening here is that some atoms of carbon have 6 protons. I should say all atoms of carbon have 6 protons, but some of them have 7 neutrons. Some of them have 8 neutrons. And so this atomic mass represents an average of all of those different atoms added up. So most of the time with carbon, you're going to see 6 protons, you're going to see 6 neutrons, although sometimes you will see 7 neutrons, as is the case with carbon-13. And those are really interesting and useful pretty often. Within biology, we can use it to like track things down. If we inject some carbon-13, we can follow it. And we can use that as sort of like a marker. But we'll get to that later on. Let's talk more about the periodic table. So it is arranged according to the number of protons. Hydrogen has 1 proton. Helium has 2 protons. Lithium has 3 protons. Beryllium has 4 protons, etc., etc. And it lists them in increasing order of number of protons. The other thing to know is that each vertical column going up and down represents a family of elements. And so lithium, sodium, potassium all have similar properties. These are very reactive metals. So the first way in which the periodic table is arranged is number of protons. The second way is that if you look up and down on these columns, you will find elements with similar properties.